In this video, we will discuss the various hose loads on the new Durham Fire Department engines. It's important to note that our hose and nozzle package has not changed. It is the same as previous engines with the exception of the 2.5, which is now Key True ID. On the rear of the new engines, going from left to right, we have 200 feet of 1.88 with a fog nozzle, 200 feet of 1.88 with a smoothbore nozzle, 550 feet of dead-loaded 2.5 with a smoothbore nozzle, another bed of 550 feet dead-loaded 2.5 with a smoothbore nozzle, 200 feet of 2.5 pre-connected with a smoothbore nozzle, 400 feet of 1.88 with a smoothbore nozzle, and lastly, we will have 800 feet of 4-inch LDH supply hose. Our pre-connected hose lines are now single stacked, so they are loaded on top of one another instead of side by side like the previous cross lays. To pull, you pull like you previously would, shoulder your shoulder load, and then reach back to pull your drag loop for your drag load. The 400-foot line is a long pre-connected line. It will be at the discretion of the company for specifically how they want to load it and how long they want it to be. Each engine is provided with 400 feet for this load. What is shown here is one method for how to pull and pack this 400-foot line. This method is a two-person pull. The first person shoulders 150 feet, the second person shoulders another 150 feet, and then also has a 100-foot drag load to pull. Now for repacking the hose loads. To pack the 200-foot pre-connected hose loads, you first start with a 100-foot drag load, and then you have your 100-foot shoulder load on top. The drag loop for the drag load should ideally be put at the bottom as shown. However, it can also be put at the 50-foot mark. That will be at the discretion of each specific company. The red 200-foot pre-connected fog line, the orange 200-foot pre-connected smoothbore line, and the green 200-foot 2.5 smoothbore are all packed in the same manner. For the 400-foot line, repacking it is slightly complicated. However, it allows for ease of pulling and stretching more efficiently. To start, we load our 100-foot drag with the drag loop at the bottom as shown. Next, we load our 150-foot second person shoulder load. And then finally, we load the first 150-foot shoulder load. This is where it gets a little tricky. To pack the first 150-foot shoulder load, as shown, a 50-foot section with the female coupling out gets loaded first and placed over top of the hose bed to connect at the top. Next, the nozzle gets placed and 100 feet is loaded on top like a normal shoulder load. Then that 50-foot section is connected and continued to load to finish off the 150-foot shoulder load. Please note to be careful when repacking hose, specifically when leaning on the crossbar due to the amber directional lights that are mounted to it. Now Chief Ray will discuss the process of packing the two 550-foot beds of 2.5 for consistency throughout the department.
With the new engines, 550 foot of 2.5 standard hose bed. One of the things that we're trying to do is come up with a standard of how we want you to rack the hose. And for the first 250 foot, it's going to be a simple, we're going to start on the right side of the hose bed and we're going to work our way back to the left. As you can see, they're working the hose down, making sure the folds are even. They work it back to the front, and to the rear, all the way over to the left side. They go all the way back. Once they make it all the way back, that's one row across. The second row will then come all the way back to the right and start working it back that way. So each level will be a row of 3, and again, it's designed to be loaded right to left so that when you deploy the hose, you'll actually deploy it from left back to right. Again, they've made it all the way across to the left. On the 3rd row, they're going to bring it all the way back to the right again and continue their load until they get to 250 feet. We've got our 250 feet loaded in the bed. Now we're going to start our 100-foot stacks, and we start with the first one to the far right of the hose bed again. So the reason for this is that when you finish out the hose load and you're actually deploying the hose from the rear of the bed, you can walk up to it and shoulder it on your right side just like you would the pre-connects. Again, these are just the 100-foot stacks, and it's loaded right to left. One of the things that you will notice is that we're stopping it at the 8-foot length in the bed. We're utilizing just a bolt on the side of the hose bed as our mark, and you can see it's similar to that of our 1.88 pre-connected hand lines. As you can see, we're loading the hose right to left. This is the final 100-foot stack. This would be the first 100-foot stack that you would deploy, and it's on the left-hand side of the hose bed when you're facing it from the rear of the apparatus. Again, that's to work with putting it on your right shoulder so that you can shoulder it in a very similar fashion to that of the pre-connected hose lines. And as they're loading it, one thing to keep in mind too is that with new hose, the new hose needs to be worked. It may appear that it's got some air in it. All that will work out with time. One of the things that I would encourage you to do is stretch and pull the hose from the rig. All it'll do is it'll help that hose. And they're finishing out the load now. 250 foot of a flat load, 3 100-foot stacks. You'll deploy it left to right. You will load it right to left. And lastly, one of the things, if your company decides that you're going to ride with the mercury monitor pre-connected, you'll do it on the white hose bed. And you'll see that they're making the connection now. And one of the things that they'll do is they'll dress the hose back a little bit to make sure that that nozzle rides flat and doesn't run the risk of falling out. Lay it to the side just as you see there for ease of deployment.
This is the front bumper line load, which is 150 feet of 1.88 with a fog nozzle. This load could possibly be used for fire attack as well as a trash line, vehicle fire line, etc. This is specifically loaded as a Scorpion type load. However, it will be up to the individual company for how they want to specifically load it. But here is one particular way to pack and pull it. This load has a 50-foot donut roll with 2 50-foot horseshoe sections with drag loops. Now Chief Ray will go over the mercury monitor and the 4-inch supply hose.
Richard Ray here again. With the new engines that are coming out, we've acquired a new piece of equipment. This is called a mercury quick attack monitor, designed to be utilized with 2.5-inch hose. So the beautiful part about this particular monitor, this is a large volume delivery device of water. For larger fires, it's quicker than our current deluge gun setup. We have this in addition to the deluge guns on our new engines. But this is a much quicker, more portable, large water device. To begin with, the tip that's on it is an 1 3/8 tip. 1 3/8, it's 500 GPMs. So for 500 GPMs, one line with a 2.5, the friction loss is 50 PSI per 100. 50 PSI per 100 is the friction loss. And then when you add the tip, we know that for a master stream, large stream of water, 80 PSI for a smoothbore tip. So to get to the correct pump pressure for this particular tool, it would be 50 PSI per 100, and then we would add 80 for the tip. A couple things about the tip itself. In terms of of operation, simple open, close. So we open it, we can move it right, we can move it left, we can move it down, we can pull it up. Now, it will go down to a certain degree, I think it is 10, but you can't, in order to get it to stay there, you have to hold it, otherwise it's gonna come back to a more operating position, normal position. In addition to the portable monitor being something that you can move around as you need it, one of the things that you can do once you've used it, you can leave it in place and you can reduce down and add on a bundle off the end, or you can simply add the 2.5 and come off the end of the portable monitor. In other words, once you've used it, you don't have to take it out of play. You can continue to use it by adding a bundle off the end or extending off the end of the monitor itself. And lastly, it has a strap. If we do have to leave this the portable monitor unmanned, it has a nice piece of webbing strap that we can utilize. It's got adjustments on it, however we need it. And we can set an anchor just to help hold it in place. The portable monitor is much like the Deluge gun. A lot of the same components. The big thing about it is that it is portable. It's much smaller. It's one line, 500 GPMs, a valve to open and close. And we can reduce the size of it if we need to move it around. And if we want to put it in place, we simply extend the legs. Again, 50 PSI for the friction loss per 100 foot of hose, 2.5-inch hose, with a nozzle pressure of 80. The next addition to the new engines are that we're moving from 5-inch supply hose to 4-inch supply hose. And there's a couple reasons for that. One, so we can get a little bit more hose in the bed, but two, this is considered a tack hose. If you'll notice, the pressure test is to 300 PSI. Our current 5-inch hose that we have is only pressure tested to 200. This is a critical component when we start talking about pumping to some of the high-rise buildings that we have downtown and some of the new ones that are on the books to be built. So the big reason for switching to it is that it gives us a higher pressure rating that we can work with. Now, there is some friction loss that's tied to it. The coefficient for our supply line, our 4-inch hose, is 0.15. 0.15. So a simple way to remember is that per 100 foot for 1,000 gallons of water, it's 15 PSI. The 4-inch hose also comes with 5-inch couplings, so they'll work with our ladders, with our current FDCs that have the Stortsless connections. Now, how much hose will you have? There'll be 800 foot in your supply bed. You'll have a 50-foot section, and then you'll have two 25-foot short sections that you can use when operating around the truck in close proximity to hydrants.